Hi there, this is the video lesson for 6-4. This is called application because what we're going to be doing today is looking at writing a system of linear equations to solve a real-life problem. So we're going to take what we've learned about linear systems and apply it into some new situations. Let's take a look at example number 1. It says Alexis has 2 more white t-shirts than black t-shirts. She has a total of 8 black and white t-shirts. Now, which system of equations could be used to represent the situation? We have some choices here. Do you see how it tells us she has a total of 8 black and white t-shirts? So if I take the number of black plus the number of white t-shirts, I would have 8. Well, take a look at your choices. Which one of your choices say that there's 8 black and white t-shirts? Do you see here and here? So it has to be choice A or B. Now, there's one other equation. It tells you that Alexis has 2 more white t-shirts than black. So one of these other equations has to represent that situation. Do you think you know which one it is? If you want to pause the video and try and figure it out, you sure can. She has 2 more white t-shirts than black. Well, let's set up a quick little table to see this. Here's white t-shirts, here's black. It says she has 2 more white than black. So if I had 6 white, I would only have 4 black because I have 2 more white than I do black. Now, take these numbers and plug them into your equations that you have here. Which one makes sense? Do you see here if I plug in 6 white and 4 for black, 6 equals 2 plus 4. That's true. Let's look at this one. If I plug in 6 for white and 4 for black, it says 4 equals 2 plus 6. That's not true. This is one way of determining which set of systems the answer would be. Choice A makes the most sense. All right. Now, we could solve the system as well, but we're not asked to solve it in this question. We're just asked to pick which system of equations would actually work. So we're done. Number 1. Let's look at number 2. It's asking us to create a linear system of equations to model the situation. We have 4 choices of systems. This is about a rectangle. A rectangular field is 35 meters longer than it is wide. The length of the fence around the perimeter is 278. It tells us that the perimeter is 278. So that means if we add up all the sides, the perimeter all the way around would be 278. Now remember, all the way around is made up of the width, the length, the width, and the length, all of them added together. Do you see how that's 2 widths and 2 lengths? So to get the perimeter, I would have to take 2 widths plus 2 lengths. And that would give me the perimeter. And we know that the perimeter is 278. So which set of systems tells us, oh, I totally messed this up. Okay, hold on, 2 lengths, and then I wrote a W. You probably caught that. Okay, 2 widths plus 2 lengths equals the perimeter. Sorry. Do you see how this equation tells us that? And this equation tells us that, but not these. Okay, now I've narrowed this down to a 50-50 choice. Now let's look at the other part. A rectangular field is 35 meters longer than it is wide. So the length right here is 35 meters longer than the width. So I could say that the length is 35 meters longer than the width. If I took the width and added 35, I would have the length. This part right here, that's our length. Here's our width. If I represented width with a W, this length would be 35 plus W, wouldn't it? So take a look for this equation. It looks like it matches with this one. Answer would be B. That would be the system. Now I could solve the system to figure out how long, and how wide it is, but we're just asked to pick which system. Let's look at number 3. All right, number 3. Again, this is a very similar question. The rectangle shown has a perimeter of 34. So remember, that's width plus length plus length. So we've got 2 widths plus 2 lengths gives us our perimeter of 34. Look at the sets of systems here. Which ones say that? Can't be B, can't be D. Okay, now let's take a look at the other part that it tells us. It says the length is 5 more than twice the width. So this length right here is 5 more than twice the width. Well, I have to pick which one of these equations tells me that. I'm going to take this sentence and I'm going to change it into an equation. Length, and is means equals. 5 more than, 5, and what could I use for more than? What symbol? Maybe a plus sign? Twice the width. What could I write for twice the width? Well, twice is doubling something, so 2 times the width. The length is 5 more than twice the width. The length is 5 more than twice the width. I just changed this sentence into an equation. Now do you see how it matches this equation right here? So the best answer choice would be C. Length is 5 more than twice the width. Now we did something like this, try and remember, earlier in the year, where we wrote a picture of a rectangle. We said, if this was the width, how would you describe the length? The length is 5 more than twice the width. So we said, well, this down here will be 5 more than twice the width, right? And so that's how we would describe this length. So length is 5 more than twice the width. You could think of it that way too. But they're not asking us to solve anything. They just want us to pick the system. Okay, so we found the system that works and it's C. Let's look at number 4. Okay, here we have a board game. Judy scores 5 points more than twice the number of points Anne scores. Wow, okay, that sounds kind of confusing. Then let's look at the second part here. It says there was a total of 65 points scored. So it looks like Judy and Anne are playing this game. And together they score a total of 65 points. So if I take the points that Judy scores plus the points that Anne scores, I would get 65 points. Hopefully you can agree with that. Now take a look at the systems. I see Judy plus Anne is 65 here. Judy plus Anne is 65 here and here. So can't be B. B, you're out of there. All right, now we're going to have to go back to this other sentence. Judy scored 5 points more than twice the number Anne scored. Which one of these equations represents that scenario? I'm going to take it right down here. I'm going to just take each one of these words and change it into a symbol and a number. It's kind of like texting, right? We change everything and shorten it up. So Judy scored. So Judy's score is equal to, right? Judy's score is 5 points more than. So 5 points more than means to add, okay? Now we have twice the number of points Anne scored. So we want twice the number that Anne scored. When you twice something, it's doubling it. So twice Anne's score. So let's look at this again. Judy's score is equal to, 5 more than twice Anne's score. I think this looks pretty good. I just changed the sentence into an equation. Now let's see if it matches up with any of these three. Did you see it? Right there. Answer's A. This system of equations can be used to figure out how many points Judy and Anne both scored. So if I were to solve it, I could figure that out. Let's just try that. Let's try solving it. So I have Judy plus Anne equals 65. And then I have Judy is equal to 5 plus 2a. Now notice how this equation here and this one we could kind of think this as standard form. The j and the a are not isolated, but do you see in this one how it says j is equal to this expression right here? So the best method to solve this would maybe be substitution, because I know that j is 5 plus 2a. Let's go into this equation up here, and we're going to plug 5 plus 2a right up in here for j. So instead of writing j, I'm going to write 5 plus 2a. Okay, so I just replaced the j with that. Now I'm going to write plus a equals 65. Now let's solve for Anne's score. Anne scores 20. Now we know that Judy plus Anne got 65 points, right? So if Anne is 20, Judy plus Anne's score, which is 20, has to equal 65. So then what would Judy have to have scored? Well, she must have scored 45. So 45 is Judy's score. So here we can see Anne is 20 and Judy is 45, and we were able to figure that out. Now it tells us that Judy's score is 5 more than twice Anne's. Well, if you double Anne's score, that's 40. And if you add 5 more, there it is, 45. It works out. Okay, let's look at number 5. A woman is 3 times as old as her son. In 13 years, she will be 2 times as old as her son will be. So here it's saying a woman is 3 times as old as her son. Okay, so right here, I'm going to take that part and I'm going to rewrite it as an equation. A woman is 3 times as old as her son. So that looks like if it's 3 times her son's age, it's triple, right? 3 times as old as her son. So woman is 3 times her son. So looking at the equations, this one, choice A, doesn't have that. But this one does, and so does this one. Now let's take a look at the second part. In 13 years, she will be 2 times as old as her son will be. So the woman in 13 years, the woman in 13 more years, so if we add 13 more years onto the woman, it will be equal to, she will be 2 times as old as her son will be. So 2 times as old as her son will be. Well, remember, that's in 13 years. So we have to take her son's age and add 13 years, right? Now, I know that what I'm setting up here looks complicated, but if you look at the choices, this one right here says the woman is 2 times as old as her son. That can't be. That's not what this sentence is saying. So C is out of there. It's got to be one of these two, okay? So do you see how if we have the woman in 13 years, right? Here this says woman in 13 years, and then we can see that the woman in 13 years is equal to her son in 13 years, and double whatever that is, right? 2 times as old as her son. So I think that this one would match it up best. Let's try it and see if it works. Okay, so we've got this first equation here. The woman is 3 times as old as her son. What I want to do is I think I'm going to use substitution. I'm going to check and see if this works. W is 3s. So I'm going to take the 3s and I'm going to replace it into the other equation right in here for w. Okay? So let's rewrite this equation. I'm just going to go right over here and do it. Instead of w, I'm going to put 3s because w equals 3s. So the w, I'm going to change you to a 3s. And then let's rewrite the entire thing. Plus 13 is equal to, distribute right here, 2s, and then plus 26, right? Okay. Let's see if this works. I have a 2s and a 3s. This is the bigger party, so I'm going to subtract 2s. 3s minus 2s is s. And here's 26. The son's age is 26 minus 13. The son's age is 13. Okay? Now, if I go back up into the top equation to my package, the woman's age is 3 times the son. So the woman's age is taking the son's and multiplying it by 3. 13 times 3, 13 plus 13 plus 13, that's 39. So, if the son is 13, the woman is 3 times as old as her son. That's 39. That works. But let's check the second part. In 13 years, she will be 2 times as old as her son. So let's look. What's going to happen in 13 years? So if I take 39 and I add 13 to it, for 13 years, in 13 years, she'll be 52. Now, how old will the son be in 13 years? In 13 years, if I add 13, that's going to give me 26. So in 13 years, the son will be 26 and the mom will be 52, or the woman. And it says that in 13 years, so let's check. In 13 years, will she be 2 times as old as her son? Yeah. This is 2 times as old. It worked. Our answer choice was B. So we kind of narrowed it down, figured it could be B. We substituted this in just to double check it, and our work made sense. It worked out. So best choice is answer B. It took a lot of work for that one, though, but it's worth it. All right, let's take a look at number 6. Here we have Mega Music Mania and Sweet Tunes. And it looks like you pay a fee to be in a club, and then you can purchase songs. So we're asked, how many songs would you need to download for the cost to be the same of both clubs? Well, you see, Mega Music Mania only charges $5 to be in the club, but they charge $2 for every song. That's pretty expensive. The other place, Sweet Tunes, they charge a bigger fee, $11, but their songs are only 50 cents. So at some point, the cost is going to be the same. How many songs would you download for the cost to be the same? Let's set up a system. I think we can do this by graphing because we can write both of these equations, y equals mx plus b. So I'm going to start with Mega Music Mania. And I'm going to write an equation for Mega Music Mania. And then I'm going to go to Sweet Tunes. And I'm going to write an equation that represents the cost of Sweet Tunes. All right, let's do this. Mega Music Mania, $5 fee to be in the club. So there's your starting $5 fee. Then they charge $2 for every song. So this is $2 per song. Okay, and then let's set up an equation for Sweet Tunes. So Sweet Tunes charges a pretty hefty fee, $11. So there's our starting $11. But then their songs are pretty cheap. They're 50 cents for each song. So if I take 50 cents and plug it in here, that doesn't really help me graph because 50 cents isn't a very nice slope. But I know that 0.5 is also the same as 1/2. So I'm going to do 1/2, 50 cents per song. So notice that the X is the songs. $2 per song, 50 cents per song. So the X-axis down here, this is going to be songs. Now remember it says y equals y. This y is equaling the cost. The cost equals this. The cost equals this. So on the y-axis, this is cost or money, okay? So right up here is money. Now let's graph this. So Mega Music Mania starts at $5 to be in the club. So I'm going to go right to the 5 and make a point. That's where we start. $5 to be in the club, and then they're going to charge you $2 for each song. So I'm going to go up $2 over a song, up $2 over a song. Remember, this is 2 over 1. Up 2 over 1, up 2 over 1, and so on. So this line represents the cost of Mega Music Mania. Now notice how the cost rises very quickly because their songs are expensive. The rate that they charge for songs, kind of high. Now, Sweet Tunes, they have a pretty hefty fee. They start at $11. So go up here to $11, make a point. That's the starting, but the songs are cheaper. It's 50 cents a song. So the slope here is 1/2. The change here is one song, or 1/2, 50 cents per song. So we're going to go up 1 over 2, up 1 over 2. There you go. They cross up 1 over 2 and so on. So do you see here how they start more expensive, but the rate of charge for the songs is a little bit less here. So we see that it doesn't climb very quickly, but there is a point that they intersect at, and that's right here. Okay, so right here at this point, that's when the cost is going to be the same for either place. Let's look at what that point is. So start at the origin. Looks like I have to go over 4. I go over 4 here, and then I have to go all the way up to 13. So it looks like it's 413. Now what does that mean? We went over 4 songs and then up 13 on the cost here, $13. So this is 4 songs, $13. So how many songs would you need to download for the cost to be the same? 4 songs. So if I plan on only downloading 4 songs, I could go to either place, because either place it would charge me $13. But if I planned on, downloading more than 4 songs, I might want to go to the place that's going to be cheaper, because after 13 songs, Sweet Tunes would be cheaper. If I wanted to download less than 4 songs, look at these two here. On the left side here, this is less than. So if I want to download less than 4 songs, I probably want to go to Mega Music Mania here, because this would be cheaper. It's lower down there for cost. But to answer the question, right here, 4 songs, $13. Doesn't matter where you go. Number 7. Here we have theater tickets. Adult tickets to a play cost $22. Tickets for children are $15. Tickets for a group of 11 people cost $228. And they're asking us to write and solve a system of equations to figure out how many kids and how many adults were in the group. Remember, there was 11 people, but how many of each were there to get us $228 cost? There could have been 5 and 6. There could have been 7 and 4, 8 and 3, 9 and 2. Any one of these possibilities is going to give us 11 people. But how many were there for this cost, $228? So we need to set up a system in order to solve this. We know that there were 11 people. So if I let A equal the adults in the group and let C equal the children, I could set up a system. There were 11 people. So the number of adults plus the number of children equals 11. Now right now all of these equal 11 if I add them together. So I can't cross off any of my choices. I need another equation. Let's write our other equation having to do with money. Adult tickets and children tickets. So right here, the first line, let's write an expression that represents the cost of adult tickets plus the cost of children tickets equals the total cost. We know that they spent $228. There's your total cost. Well, how could I write the cost of the adult tickets? They're $22 each. So $22 times the number of adult tickets. That would be the value. And children, I bet you can guess that would be $15 times the number of children. So here we have a linear system. Now we have choices here. So what you could do is you could figure out $22 times how many tickets, how many adult tickets, plus $15 times how many children tickets gives you $228. You could just plug in the choices. You wouldn't even need to solve. You could try 8 and 3 and see if you plug in 8 and 3 here, does it give you $228? You could take 7 and 4 and plug that in. Try that. You could try 6 and 5. You could try 9 and 2. That would be a great strategy. Plug it in and try it. Okay. Another strategy is you could solve the system. Do you see how the A's are lined up, the C's are lined up, and the constants lined up? So because everything's lined up nicely here, I could just use elimination to solve. So if I use elimination, I would have to get maybe the A's to cancel or the C's to cancel. Maybe since 15 is less than 22, I could multiply everything in the top by negative 15. So if I solved it by using elimination, I'll multiply everything up here by negative 15. And then I'm just going to copy this over here. This would be negative 165. Okay. Then the second equation is going to stay the same. So I'm just going to add these two together now. So I have negative 15 plus 22. Remember, these canceled out. And then here I have negative 165 plus 228. And 63 divided by 7 is 9. So the number of adult tickets is 9. So then if I go over here to my choices, the only one with 9 adults is this one, because I know that adults plus children is 11, so 9 plus 2 is 11. Now, let's just check this. What if I didn't spend all the time solving this? Remember at this point I told you you could take these choices and plug them in? So what if I would have just done that? 9 adults right here and 2 children. Let's see how this works. So if I use my calculator and go 22 times 9, that's 198. Plus 15 times 2 is 30. And then does that equal 228? So you just, use your calculator, and if you add these two together, you get 228 equals 228. And you're like, yes, that checks out. That's perfect. So that must be the answer. So I wouldn't have needed to go through all of this work unless you really wanted to solve the system. You could just plug in the answer choices and figure it out. All right, that was number 7. So here we have number 8. Now there's no choices for number 8, and there's also no choices for number 9. We're completely on our own here. So let's see if we can set up our system. Julie went to school supply shopping. She spends $26.88 on notebooks and pencils. Notebooks cost this, pencils cost this. And it tells us that she bought a total of 20 notebooks and pencils. But how many of each did she buy? Did she buy 10 and 10, 8 and 12, 14 and 6? I mean, there's so many possibilities that add up to 20. So writing a system will help us determine exactly how many notebooks and pencils she bought to spend this amount of money. Okay, let's first start by looking at the 20 notebooks and pencils. If we say that N equals a notebook and P equals a pencil, let's write our equations. 20 of them. Would you agree with me that if I took the number of notebooks plus the number of pencils, it would equal 20? Sure. Now, I could put different numbers in here. Like I said, you could put, 12 and 8. You could put 18 and 2. Lots of possibilities to give me 20. We need another equation. Let's write the other equation with the money, the value. So here we want the value of the notebooks. Just because this is N, we'll do notebooks first. Notebooks are $2.24. So $2.24 times the number of notebooks. Plus pencils. Those are cheaper. 96 cents per pencil. Maybe that's a pack, who knows. Be sure you put your decimal points in. And then that equals a total of $26.88. Now I have 2 equations, which makes a system, and I can solve. Now, do you see how the notebooks here are lined up, the pencils are lined up, and the constants lined up? It's perfect for elimination. However, I can't get anything to cancel without multiplying here. I'm definitely going to need my calculator on this one. So either I have to multiply the top by negative 2.24 to get the ends to cancel, or multiply the top by negative 0.96 to get the pencils to cancel. Maybe let's do negative 0.96 because it's smaller. negative 0.96. So everything is going to get multiplied by that. So this is going to become negative 0.96 n, and then minus 0.96p. And then here I have 20 times negative 0.96. And that's negative 19.2. Careful with all these decimals. Now we're going to copy down the second equation directly below. $26.88. You're really going to have to rely on your calculator with this. Do you see what happened here? The negative 0.96 and the positive 0.96, they're going to cancel out. So now let's add these two together. So I'm going to type in negative 0.96 plus 2.24. And I get 1.28 n. Then let's bring down the equal sign. Let's add over here. Negative 19.2 plus 26.88. Calculator says, I think I messed up on that one. Negative 19.2, sorry, plus 26.88. All right, I get 7.68. Now we have to divide, because these two are stuck together, multiply. We divide by 1.28. Yay, it came out to a whole number. Woohoo! I don't know if you can see that or not, but n equals 6. Whew, good thing. Okay, so notebooks equals 6. So we have 6 notebooks. We'll go back here. If there's 6 notebooks, how many pencils would there be to equal 20? Well, 6 plus 14 equals 20. So the number of pencils would have to be 14. That way, both of these added together give us a total of 20 pencils and notebooks. So there we have it. That's how many notebooks, that's how many pencils, and we solved it with a system. Last one. This one's all about Mr. Huss. He has a whole bunch of change in his pocket. 37 quarters and dimes in his pocket, to be exact. His change is worth $6.85. So how many of each kind of coin does he have? How many quarters, how many dimes? We know that there's 37 total, but how many of each are going to equal this amount? Let's use Q for quarter and D for dime. Okay, the fact that he has 37 quarters and dimes, we could set up that equation. If I take the number of quarters plus the number of dimes, it equals 37 in his pocket. A lot of change. Now the second equation, we know that the change is worth $6.85. So we know that the total it's worth is this. But that's all the information they give us. Now remember, if that's the total value in the pocket, think about what's the value of a quarter and what's the value of a dime. You know that a quarter is worth 25 cents and a dime is worth 10 cents. That's the value. So I can use that to help me set up the equation. A quarter is 25 cents. So 25 cents times the number of how many quarters he has in his pocket.